So the remainder of the problem will be devoted to finding the maximum height of the ball. And here's how I will propose to do it. I'm going to cut this piece. And I'm going to solve it separately as if it was flying from the ground. And we have seen those cases before. So that's the maximum height that we need. So in this scenario, I repeat the same steps. VIX multiplied by time. I pretend now that the ball is being thrown from the ground. There will not be initial height. V initial y multiplied by time. 9.8 t squared divided by 2. And I remember saying that at the point of landing, which currently I assume happens here, y is 0. What I want to take from here is find time when this happens. So let's look at the second equation. And instead of v initial y, I am using 19. So one of the t, which is 0, I have no interest in. And the other t will be 19 divided by 4.9, which hopefully is, oops, I apologize. It's 3.9 seconds. Half time. Why do we need half time? Half time is maximum height happens at half time. At half time, which is 3.9 divided by 2. I have it as 1.95 seconds. And that's basically it. So we found the critical point. We found the time of this. So maximum height happens at time equals 1.95. All we need is just to put this time into the equation of this line for y, and we will be able to calculate it. We can use this equation. We just need to remember to add 30 at the end, or we can just reuse the equation that we had originally, which was y equals 30 plus 19t minus 9.8 t squared divided by 2. It was our original equation, which was here, right here. This is it. So we can use that. And so when we put 1.95 in there, I will write this, but I'll leave it for you to do the calculation. 9.8, 9.95 squared divided by 2 equals, so you will do all these calculations. And hopefully arrive to what looks like 48.7 meters. So maximum height is 48.7 meters. Now we actually have found everything that we possibly can from this question, and we consider the problem resolved. There could be, how do we know it's true? How do we check our answers? And those are valid questions. So what we did with grade 12s, I'll show you. We created in Desmos a model of projectile motion. So this projectile motion can be modeled in Desmos, and we just need to put our initial data. Right here, our angle was 50 degrees, like so. And it gives us pretty much everything. Here's our 48.7, the maximum height, which we found earlier. Here's our range, 82. We also found that earlier. 30 is where the object had started. It doesn't tell us what time will be here, but somewhere down the road, I think I have time. 5.1 is the time of the full flight, and we also had this calculation, and we actually had velocity at the end, 34. I don't remember where we had that. And yes, we had 34. Angle 62, did we have that? I think we did, 62. This is negative, meaning that it's pointing down, but regardless. So this model allows us to basically know all the answers right away. Isn't it beautiful? Yes, that's grade 12 coming. Thank you for watching.